This is the second part of the video lecture for Math 140 for Thursday, April 30th. And again, the topic today is the circle. And in the first part of the video, we derived an equation for a circle, and we talked about how to graph a circle. In the second part of this video lecture, we're going to do 3 example problems relating to circles. The first problem is find the equation of a circle centered at -1, 2 with a radius of 3 and graph it. Okay, if this is the center of the circle, then we immediately know that h is equal to -1 and k is equal to 2. And we also know our radius equals 3. Well, let's recall the equation of a circle. The equation of a circle is r squared equals x minus h squared plus y minus k squared. Okay, so all we really need to do here is just plug in these numbers, and that leads us to an equation of 3 squared, which equals 9, is equal to x minus 1. Now we need to be careful here because h is -1 and we have a minus sign. So we have x minus -1 squared plus y minus 2 squared. And this leads us to the equation of our circle. 9 equals x minus -1 is x plus 1. X plus 1 squared plus y minus 2 squared. So this is the equation of a circle that's centered at the point -1, 2 and has a radius of 3. Okay, now we want to graph this, and actually what I'm going to do here is instead of graphing this on the board and creating a coordinate axis system, I'm actually going to show you guys in Desmos what the graph of this looks like. So let me type this in. I get the equation 9 equals x plus 1 squared plus y minus 2 squared. Okay, and now I'm going to show you guys what this looks like. So this is our graph in Desmos. Let me see if I can zoom in this. I'll zoom out again. Okay, anyway, this is our circle, and note that the center of the circle is at the point x equals -1 and y equals 2. So our center is right there for this circle, and this circle has a radius of 3. For example, this point right here has an x value of -1. That means if we go horizontally to the edge of the circle, right, we should have to go 3 units to the right, or go 3 units to the left, and then we'll get the circle. And one way to graph a circle, if you don't have Desmos, you're graphing it by hand, a really good way to graph it is place the center on your coordinate axis system. And what I like to do is I like to place then 4 points. I go vertically up by the radius, in this case of 3. I go to the right from the center by exactly 3. I go to the left from the center by exactly 3. And I go down by exactly 3. And that gives me 4 points on the circle. And then with those 4 points, I'm usually pretty good by hand at completing the circle. So that's a way you guys can create a quick graph of the circle. I hope that made sense to you guys. Okay, that's our first example problem. We're going to do 2 more examples, so let me erase this. Okay, our second example problem is a problem where we have to graph. So we want to graph the circle that's represented by the equation x minus 2 squared plus y plus 3 squared equals 5. So suppose we're given the equation of a circle. And by the way, again, this is the factored form of the equation of a circle. This is a specific circle. We want to graph this circle. The first thing we want to do here is identify our radius r and our center hk. Okay, well, let's write down the equation. The general equation for a circle is x minus h squared plus y minus k squared equals r squared. So if we compare these 2 equations, we immediately see that r squared is equal to 5, right? Comparing these 2 equations. And that means if we solve for r, we take the square root of both sides. And that means r is square root of 5. So we immediately know our radius is square root of 5. And if you guys plug this in your calculator, that comes out to approximately 2.24. Okay, so our radius is 2.24. Now we want to find the center. So we compare these two equations. And the first comparison I'm going to do in x, in terms of x. If I look here, I notice that minus 2 and minus h should match. So I get the equation minus h equals minus 2. And if I solve this for equation for h, this means h equals 2. And then we can do the same kind of matching thing for the y values. And looking here, I see that minus k equals plus 3. Okay? So minus k equals 3. Okay, comparing these two things. And then this means that if I solve for k equals minus 3. So now what I found is the center. So the center of my circle, which is hk, right, is hk. The center of my circle is 2 minus 3. So now I found the radius and I found the center of my circle for this simple equation. And the next thing we can do is graph this. And once again, I'm going to rely on Desmos to create this graph. So just give me a second as I type up the equation of this circle. We have 5 equals x minus 2 squared plus y plus 3 squared. And this has now created a graph. And let me just move this around a bit. So let me show you guys this graph. Okay, that's the graph of this circle in Desmos. And the center of this circle looks like it is at the point x equals 2, y equals minus 3, which is just as we would expect. As we found on the board, our center was 2 minus 3. And in addition to that, the radius should be square root of 5, or about 2.2, 2.3. And for example, if you start right here, we go over to the right by 1 unit, 2 units, and then a little over 2 units, about 2.25 units, okay? So it appears like the radius here is correct. And so this is a graph of this circle. Okay, I hope that made sense to you guys. Okay, that's our second example problem. We're going to do one more example problem. And what I want to do here is, before I do the third example problem, what I'm going to do is I'm going to take this equation of this circle, and I'm going to actually square this out. So let's look at this equation. We have x minus 2 squared plus y plus 3 squared equals 5. What I'm going to do is I'm going to square out these terms now. So if I do that, if I square these terms out, I get x squared minus 4x plus 4. If you take x minus 2 squared and FOIL it out, this is what you get. And then if I do the same thing for the y term, I get y squared plus 6x plus 9. And all of this equals 5. Okay, and then what I'm going to do is I'm going to start kind of rearranging the order of these terms. And so I'm going to rewrite this as x squared plus y squared, okay, minus 4x. Excuse me, this is a y. I'm sorry, I don't know why I put an x there. That's 6y. Minus 4x plus 6y. And then I have a plus 4. I have a plus 9. And then I'm going to bring this 5 over to this side. I'm going to subtract 5 from both sides. So I get minus 5 equals 0. And then the final step here is I'm going to combine these numbers. So I get something that looks like this. X squared plus y squared minus 4x plus 6y. This is 4 plus 9 is 13 minus 5 is plus 8, right? Equals 0. Okay. What I have here is an alternate way to write the equation of a circle. This is still the equation of a circle, but it's in a different form from this form. This is called the factor form, and this is called the polynomial form. This is called the polynomial form of the equation of a circle. So, in other words, we can represent a circle as a polynomial, as a second degree polynomial in both x and y. because we have an x squared and y squared. Then we have the first degree terms, minus 4x plus 6y. Then we have a constant. So we can represent a circle as a second degree polynomial in x and y. Now here's the question. If we were given this equation as our equation of the circle, so let's say we started with this equation and we wanted to know what the center of this circle is and know what the radius is and be able to graph it, could we do that? And the answer is yes, we can. So basically what we do is we go in reverse. If we started with this, we have to kind of go backwards and see if we can rewrite this in the factored form. Because the factored form is very easy to quickly identify what the center and radius is of our circle. Whereas this form of a circle, it's difficult to tell immediately what the center and radius of the circle is. So the goal here is to be able to take an equation of a circle like this and go backwards. And the way we do this is we do something called completing the square. And this is an operation that's used in algebra. Basically, if you have a quadratic, I'm not going to get into the details of this, although you will need to know how to do this, but I don't want to get into all the theory behind it. But if you have a quadratic equation, okay, there are three ways to solve that quadratic equation. You can either factor it, or you can use the quadratic equation. Or the third way is to do something called completing the square. So we're actually going to take this equation and we're going to complete the square in both x and y to turn it into the factored form. Okay. So let's do an example. Let's do a different equation than this. So that's our third example. Let me erase this. Hopefully you guys have done completing the square, or seen completing the square in some class in high school or college mathematics. So hopefully this won't be an entirely new thing. But for our third example problem, let's consider this problem. So we want to find the center and radius of a circle given by this equation, x squared plus y squared minus 10x minus 12y plus 4 equals 0. So this is the equation of a circle, although it's given in polynomial form. We want to find the center and radius of this circle, and then we want to also graph this as well. So how do we do this? The steps involved here are, I'm first going to read, so we're going to go backwards from what we just did, that previous example. So what I'm going to do is reorder things here a bit. And so I'm going to rewrite this equation as x squared minus 10x, okay? All I'm doing is reordering, plus y squared minus 12y. And then I'm going to move this 4 to the other side, okay? So I get minus 4. Now you might wonder, why am I doing this? There's a method to the madness here. And then what I'm going to do is I'm going to write this as x squared minus 10x plus something plus y squared minus 12y plus something equals minus 4 plus something. So what I'm going to try to do is I'm going to try to add a number here and add a number here that will allow me to factor this equation into what's called a binomial square. Okay. And now the question is, can I do this? Can I just add something here and add something here to an equation? Well, the answer is I can add anything I want to an equation as long as I do it to both sides. So whatever I add here and here, this has to equal what's added here. But this is totally illegal. Okay, and let's talk about a binomial square. Binomial squares is basically defined as x minus a, x plus or minus a squared, okay? And if I square this out, if I FOIL this out, this gives me x squared plus or minus 2ax plus a squared. So what I'm doing here is if I can write this like this, that means I can then factor it into something squared, okay? So the question is, what do I add? What do I add here so I can turn this into a binomial square? Okay, well, the magic formula is, basically what I do is I look at this middle coefficient of minus 10, and notice that for the first case, for this case, for x, if I compare this to this, I see that minus 10 equals 2a, and that means a equals minus 10 over 5. Okay, and that is equal to, that means a is equal to minus 2, sorry. And so what I want to do here is I want to, I got this wrong here. This is 10 over 2. It's getting late at night, so I'm having a few issues here. This is minus 5. Okay. So in this case, a is minus 5. So that means what I want to add on here is minus 5 squared. So I want to add on minus 5 squared. Let's go through the same procedure here. Okay. And I won't go through this equation again, but basically you take half of this middle term. So if I have minus 12, I get minus 6. And now I'm going to add on minus 6 squared, or add on a squared. Okay. And that means over here, since I'm adding these two things here, I have to add it over here. So I'm going to add minus 5 squared plus minus 6 squared to this side. Okay. Now let's do this. So now I get x squared minus 10x plus 25, okay, over there, plus, and then with the y's, I get y squared minus 12y plus 36, okay, and on the right side, I get minus 4 plus 25 plus 36, okay. This is called completing the square, okay. This is actually completing the square. Not only, often you do completing the square in one variable, we're actually doing it in two variables, x and y. We're completing the square. And now the beauty of this is, I can now factor this into binomial square. So this thing factors into x minus 5 squared, okay? Now if you guys aren't convinced of that, try foiling out x minus 5 squared, and you will get exactly this. So this factors into x minus 5 squared, okay? This term here factors into y minus 6 squared. Try foiling it out. It's exactly what you get. You get this back. And then over here, I'm going to add these numbers together. 25 plus 36 is 61, minus 4 is 57. So now I get this equation. This is the exact same equation as this equation. It's just written in a different form. This again is the polynomial form of the equation of a circle. And this is the factored form of the equation of a circle. Okay. But the beauty of this now is now I can quickly identify the attributes of the circle. So very quickly I see that r squared is 57, which means that r equals the square root of 57. And if you guys plug that in your calculator, you get approximately 7.5. And I can also identify the center of the circle. So the center of my circle will be equal to, I see that h is 5 and k is 6. So I've taken an equation where it wasn't obvious to me what the center of the circle was and what the radius was. I've turned it into the factored form where I can very quickly identify the radius and the center of the circle. And now the final step here is I can graph this equation. And once more I'm going to go to my friend Desmos to do this. And so in this equation I have 57 equals x minus 5 squared plus y minus 6 squared. And now I'll show you guys this circle. There we go. I'm going to show this to you guys. I know this video has gotten kind of long, but it's almost over. This is my circle, and I can see that my circle is centered at x equals 5, y equals 6. It's centered right there. Let me point this out with a pencil. That might be easier. It's centered right there. and the radius of my circle should be approximately 7.5. So one way I can test that, I can start at this point, and let's jog over to the right. 1, 2, 3, 4, 5, 6, 7.5 units. 7.5 units to the right, and I've hit my circle. So it looks like the radius of the circle is correct. And so this is our third example problem. And for the homework, I'm going to give you guys problems similar to the examples we've done. So make sure you guys know how to do them. In particular, I think the last problem is the hardest problem, completing the square. Make sure you guys are comfortable with that. If you guys have questions on completing the square, we can do another example in class on Thursday. And I'll look forward to seeing you guys then.